So that led us to balancing of chemical equations. In this case here, we want to account for all the atoms that are getting involved in the reaction. Keeping in mind that atoms are neither lost nor gained, but all must be accounted for. So when we write a chemical equation, we have to balance it to make sure that every atom is accounted for. Hence, it means that the total number and types of atoms in the reactants must be the same as that total number of atoms and types in the products. Everything must be accounted for. This means that there must be the same number of atoms of each type on either side of the arrow that's found here. On either side of the arrow, left and right, there must be the same number of atoms of each type. That's what it means. So let's look at this particular equation here. We have two reactants in our equation. The reactants are carbon and oxygen. In this case here, we have one molecule of carbon and one molecule of oxygen. Remember, a molecule is a representative unit of what's found in an element or in a compound. That's why we also have one molecule this side here. Although this time we're looking at a compound, here we're looking at simple pure elements. Now, in this case, when we look at the number of atoms in each molecule, we have here one carbon atom, and since oxygen is diatomic, we saw that before, we have then two oxygen atoms, and in one molecule of carbon dioxide, we're still going to have one carbon atom, it's justified here, and two oxygen atoms. That's justified here. So everything has been accounted for. One carbon, two oxygen, everything is accounted for. Steps for balancing a chemical equation. In this case, we will use this equation as an example. Hydrogen plus oxygen to produce water. So two reactants, one product. Our first step is to write down the symbols and formulae for all the substances. So that's what we are doing here. But while we're writing them down, especially for the reactants, remember that certain elements are diatomic. So we'll write hydrogen with the subscript 2 and oxygen as well with the subscript 2 because they are diatomic molecules. Step 2, second step, we go then make a picture like the models of the drawing or the picture drawing of the equation so that we can easily count the number of atoms that are present in each molecule, like what we have here. In this case here on the right, I'm counting now from step 3, I'm counting the atoms. I have 2 atoms of hydrogen that are represented in white on one side here, and again I try to look at the hydrogen atoms on the right side here. I still see 2, so hydrogen is balancing out. I have 2 here, I have 2 here, and on the other side, on one side, on the left side, I also have 2 atoms of oxygen, so there are 2 oxygen here, but on the right side, nonetheless, there's only 1 atom of oxygen. So in this case, I have 2 oxygen here and only 1 oxygen here. This is a problem. It means things are not balanced out. That's why we need balancing, and we'll see how to continue to fix that problem. So in our next step, step 4, in trying to fix the problem of the shortage of the oxygen atom on the right side, we'll try to make the atoms on either side of the arrow to be equal. This is our arrow. We'll try to make the atoms on either side of that arrow to be equal by this time adding more molecules, not adding atoms. We're adding more molecules to the site where we don't have enough atoms, and that site was the right side here, was on the right side. So you'll see here we've added an extra water molecule. We did not just add an extra oxygen atom somewhere here. Otherwise, it would have given us 2 hydrogen atoms, that is 2, and 2 oxygen atoms, which is that. This is not water. It gives us hydrogen peroxide. So we're not adding an atom of oxygen, no. We're adding a whole water molecule to try to fix that problem of the shortage of the atom of oxygen. Now, that's what it means. You cannot change the composition of a molecule. So we can't change the composition of the molecule by adding the hydrogen atom. So you cannot simply add another red atom to the right. That's what we're doing here. So now that we've added the water molecules, we've added the water molecule. There are now 2 of them here, 2 water molecules. I want us now to realize that it also means there are 2 oxygen atoms here and 2 oxygen atoms on the left side as well. It means as far as oxygen is concerned, it is balanced out. But when we look at what we have in total now, when we look at everything, we will then have to count the atoms on either side, and that will bring us to the realization that yes, oxygen has been balanced out, but when we look at hydrogen, I still have 2 here, and this time I have 1, 2, 3, 4 on this side here. Now there is a new problem. Oxygen has been fixed, but that has been at the expense of this damaging the order that we had for hydrogen. So now we need to also sort out hydrogen. To fix the problem with hydrogen, we'll keep on repeating step 4 and step 5, which respectively meant that we'll keep on adding more molecules and later on counting the atoms on either side. We'll keep on adding more molecules to try and balance up, and later when we're doing the balancing, we'll count the number of atoms on either side to make sure that everything matches or balances out. So that's what we will be doing here. In this case here, hydrogen was 4 on the right side and just 2 here. So we'll then need to add 2 more white atoms. Otherwise, we'll need to add just 1 molecule of hydrogen, because remember, hydrogen is diatomic. By adding 1 molecule of hydrogen, it means we've added 2 more atoms of hydrogen. That makes now, then this addition is done. We're doing it only on the left side. When this addition is done, we can now count here 1, 2, 3, 4 atoms of hydrogen. That is, hydrogen here will be 4. And that 4 is equal to 2 molecules of hydrogen. 1 molecule has 2 atoms, so 2 times H2. That's what it means. I'll have 2 times 2, that should give me 4. It means there are 4 atoms of hydrogen. Added to that, we now have on this side 2 oxygen atoms, which is the same as 1 molecule of oxygen. 1 times 2 should give me 2. On this side, I have 2 molecules of water, which are composed of 2 oxygen atoms. So my oxygen atom here also is 2 oxygen atoms. But this time I can count 1, 2, 3, 4 atoms of hydrogen. So in total, what do we have? Hydrogen on the left side is 4. That's it. Hydrogen on the right side is 4. So my hydrogen, I can tick it. It's balanced. Oxygen on the left side is 2. Oxygen on the right side is also 2. So my oxygen 2 is balanced. I can now also tick it. Now I'll write the whole chemical equation. It means everything has finally been balanced out. I'll write down the whole chemical equation and write a number in front of each formula to show how many of each molecules we have. Keeping in mind that if in front of a formula I have 1, I don't write that 1. It becomes kind of silent, but it's forever present. It's just like X is the same as 1X. So I'll only start writing anything on the side of X if it starts from 2 upwards. Then I can have 2X. So the same thing applies here for oxygen. It's supposed to be 1 here, but because 1 is silent, we don't write it out. That's what it means. So when we write down the numbers in front of each formula, if you remember when I was talking about hydrogen here, I said hydrogen is diatomic. So when we see 4 atoms, it means there are actually 2 molecules of hydrogen. It means I'm going to write 2 here in front of hydrogen to say there's 2 of this type. In front of oxygen, we used only 1. So there's 1 molecule of oxygen. And in front of water, because we wanted first to balance oxygen out, we had to bring in another molecule of water to form this compound here. Then we now have 2 molecules of water. That's why we have that 2 there. So that's how we balance a chemical equation. Therefore means that this is how our final equation will look like. Few points to remember when balancing chemical equations. The first one, remember the following. There must be an equal number of each atom on each side of the arrow. So you look at the left side and you look at the right side, make sure that the number of atoms for each element is balanced. Again, you cannot change the composition of a molecule. That's why we didn't just add oxygen atom in that water molecule. It would have given us a whole new compound, which is hydrogen peroxide, which has no property of water. So we rather only change the quantity of a molecule. We rather add another water molecule if you want to balance the equation. Again, you cannot use small numbers in the formula to add atoms. Only use the big numbers that are in front of the formula. And lastly, you start by counting oxygen atoms and hydrogen atoms in a compound or molecule if there is any in that equation. So, thank you.